Methane and ethylene gases are harmful to humans. These gases must be carefully contained at all times. A leak in one of these pipelines can become fatal dangers in plants and refineries for oil and gas, petrochemicals, and other hazardous industries. The danger lies in this: these gases are colorless, so they are invisible to the naked eye. At chemical plants, gas-fired power stations, and similar locations, natural gas is transported through pipes all over the site. The threat of leaks can be found at every turn. Danger is ever present. Over the years, many efforts have been made to monitor and detect these colorless gases. At the time of the Industrial Revolution, miners in damp blankets held out lit candles to detect combustible gases in the mines. They watched the flickering flame closely for signs of volatile gases. Later, miners would take canaries into the mines. When the noxious gases killed the little birds, the air was unsafe. The Davy safety lamps and colorimetric gas detection tubes were invented and put to use afterwards. Much later came the electrochemical sensor. This is a more widely used stationary sensor with much better sensitivity. However, this type of sensor has a limited monitoring range, is heavily affected by the environment, and needs to be replaced annually, which can become costly. Each one of the methods mentioned here requires making direct contact with the invisible gases during a leak. But imagine if there was a way we could simply see the gases instead. Furthermore, could this be done with highly efficient but cost-effective equipment? The answer is yes, and it's actually fairly simple using the infrared spectrum. Hydrocarbons such as methane, ethylene, and ethanol absorb large amounts of infrared light at wavelengths of 3.0 to 3.5 micrometers. This means that if such volatile gases were to leak, they would gobble up a very specific spectrum of infrared light in the air. Based on this principle, Hikvision developed a gas cloud imaging GCI camera to capture this effect. More specifically, the methane detection PTZ camera. With a built-in infrared detector in the 3.0 to 3.5 micrometer wavelength range, the camera acts like a pair of infrared glasses for the human eye. As the leaked gases absorb infrared waves, we can clearly see their spatial distribution from the missing parts of the reflected infrared light spectrum. Enhanced with intelligent algorithms, the camera can also monitor the trajectory of the gases and provide automated, intelligent alarms. This is a low-cost, efficient, and practical method of detection, and it is much safer, especially when compared to traditional methods. By detecting light absorption via different gases, and combining that with visible light imaging for multidimensional perception, we can use these capabilities to create a range of GCI cameras that meet specified requirements and elevate safety at petrochemical parks, oil refineries, rubber plants, steel mills, and much more. This means more safety for more people in more workplaces around the world.